Guys, Guna Math over here, and this is the 2020 SMT Discrete Math section, problem number 2. Here's a view of this problem. Find the probability that a randomly selected divisor of 20 factorial is a multiple of 2000. So we know that 20 factorial is 20 times 19 times 3 times 2, and then 1's not needed, but we'll just put times 1. So this is the expansion of 20 factorial. Now let's see what the problem is asking for. It's asking us to find the probability that any given divisor of 20 factorial is a multiple of 2000. So whenever I want to find the divisors of a number, I want to prime factorize the number, right? Because then you can easily find the number of divisors by just taking the exponents, adding 1, and multiplying them together. So our goal here would be to prime factorize 20 factorial. Now what we could do is we could do like 20, 19, 18, 17, 16, and so on, and then just like prime factorize those individual numbers and then combine them all into the prime factors. But that requires a lot of writing, so I'm gonna like think of this kind of like smartly. So how would we find the number of 2's in 20 factorial? Well, let's just write number 2's. What we want to do is we want to see, firstly, how many, so there are going to be 20 over 2, floor of 20 over 2 initial 2's in the 20 factorial, and then of those initial 2's, when undercounting those which have an additional 2, like 2 squared, which is 4, or 8 or 12, which have 2 2's in its prime factorization. So we need to account for those as well. Again, we're undercounting for the ones with 3 2's, like such as 8 and 16, and then 4 2's. And then we see that for 5 2's, the least positive integer with 5 2's in its prime factorization is 32, which is greater than 20. So we stop here. And then similarly, we have a similar logic for 3's. We simply have 23 in original run, and then undercounting the ones with like 2 3's in its prime factorization, and then so on. Actually, that's all, because then the least integer with 3 3's in the prime factorization would be 27, which is greater than 20, and then so on. So you get the point. So now let's just crunch these numbers. So 20 factorial would be equal to 2 raised to the power of, we have 10 plus 5, which is 15, plus 2, which is 17, plus the 1, which is 18. So 2 to the 18, and then for 3, we would have 20 over 3 floored, which would be 6, and then 20 over 9 floored, which would be 2, which is 8. And then we have no more. And then 5 would have 20 over 5 floored plus 20 over 25 floored. So just the 20 over 5 floored, which becomes 5, 20 over 5 is 4. And then for 7, we have the 20 over 7, and that's pretty much it. So 7, but we have the 20 over 7, which we have 2 of, because 20 over 7 is 2, the floor of that is 2. And then for 11, we would just have the singular 11. And then for 13, we'd have the singular 13. For 17, we'd have the singular 17. And then for 19, we'd have the singular 19. And then we need not go further, since 19 is the greatest prime less than 20. Great. So now we have 20 factorial prime factorized. So we can get the number of divisors. Just add 1 to each of these. And then this is 2, 2, 2, 2. I'll just write that as 2 to the 4th power. And then in the numerator, this is where like the real problem is. We want to find the number that are multiple of a 2000. So of course, helpful to prime factorize 2000. 2000 is 1000 times 2, and 1000 is 5 cubed times 2 cubed. So this is going to be 2 to the 4th times 5 cubed. Okay, so now let's see how many of these divisors can we construct with the 2000 inside. So we already need the 2000. So from the 2 to the 18th itself, we can either choose 0, 1, 2, all the way to let me write this down. So for the 2, we can select anywhere from the 0 1 all the way until the 14 remaining 2's that are left after we take out the 2000, right? So this one would result in 15 possibilities. And then similarly for 3, we can do the same thing. Well, 3, we can choose any of them. We can choose 0 up till 8, so we have 9 choices for the 3. For the 5, we can choose 5, 3, or 5 to the 4. So that's 2 for that. Okay, 7, 3, and then 7, we have 3 choices, 7, 0, 7, 1, or 7, 2. And then we have the usual 2 to the 4th over here. And then now all we have to do is simply evaluate. This goes away, this goes away, this goes away. And we're left with 30 over 95. And then we can divide a phi out. That gives us 6 over 19. And then this is going to be in most simplified form. So this is our answer. And we are done.